Yo, Chuck.
All right, guys, this video is going to be on merge sort, and merge sort is a little bit more difficult to wrap your head around, but it is not too bad once you kind of figure out what's going on. That's kind of convoluted, but let's just get started and you'll see what I mean. So the first thing you want to do with merge sort is you need to make a function that's going to merge two arrays, two sorted arrays. So I'm going to say const merge equals array1 and array2. Okay, so let's put those arrays, let's pass in some arrays here, and they have to be sorted. So I'm going to say something like this, and let's do something like this. Okay. When I say sorted, I'm just saying relative to themselves. I'm not saying they have to be sorted to each other, because what we're going to do is we're going to loop through all these values and we're going to compare each value of one array to the other, and the lower the value will be pushed into a array of result first, and then we'll move on from there. So I'm going to say let results equal just an empty array, and then I need two pointers to reference array1 and array2 indexes. So I'm going to say let I equals 0, and then let k equals 0 as well. Okay, so basically, like I said, we're going to loop through these array values, comparing array1 to array2 at index I and k, and if they're the smaller one, will be pushed into result first. So I'm going to write some logic here. I'll say while I is less than array1.length and k is less than array2.length, I want to do something. And this is where I check to see if the value of one array is less than the value of another array. So let's do that. I'll say if array I is less than array1 at index I, is less than array2 at index k, then I'm going to result push array1 at index I, and now I need to increment I, because that value that I just pushed in there needs to be not in the equation anymore for the comparison, because we're taking it out now. And then if that's not the case, then we're just going to do the opposite. We're going to push array2 at index k and then increment k. Okay, like that. So for this first iteration, we're going to compare array1 at index I to array2 at index k. And array2 at index k is actually lower, so we're going to push that into result. And then we're going to increment k. So now array2 has these two values remaining that we're going to be concerned with and doing our comparison to. So if I just return result right now, this may or may not work. Let's see. And it's not working because it's stopping after a certain point. So let's see what I is at right now. So I is at 0 and k is at 3. So what we need to do is add a little bit more code. So we'll say while I is less than array1.length, result.push, and we're going to say array I and then increment I. So what's happening is, because when we're doing the comparison, every value of array2 was smaller than array1, we're not even pushing anything in from array1. So by adding this extra while loop right here, that's going to fix the problem. So now if I return result and I put in the right array, that would help. You can see it fixed the problem, and now it's got all the values. But as a safeguard, I'm also going to do that with array2 as well. So I'll say k array2.length, array2 at k, and then k++. So that just kind of covers our bases as far as the merging goes. But now we can have different lengthed arrays and it would still work, as long as they're still in ascending order sorted relative to themselves. So this should still work, and it does. Let's add some more numbers in here. Let's add some numbers in here. So now you can see it still works. Everything looks good. So this is like half the battle with merge sort, is just creating that merge algorithm. And this is not too bad, as you can tell. We're just comparing individual values with an if statement, and then we're pushing them into result depending on which is lower, and then we're incrementing some type of index counter, in this case I and k. Okay, so that's merge function. Now let's do the merge sort function, which is the other piece. So I'm going to just delete this actually, and we're going to leave our merge function because we're going to need it for merge sort, but I'm going to say const merge sort equals, and merge sort is not going to take 2 arrays this time, it's just going to take 1 array. So let's just pass in whatever we want for our array, something unsorted. So I'll say something like this. How about that? Okay. And I'll just return that array to make sure everything's firing. And it looks nasty and unsorted. Okay, so how do we fix that? So the idea of merge sort is basically we're going to break down every element into, we're going to have every element until it's 1 or less in length. So what that's going to look like is we're going to use recursion on our merge sort, and our base case is going to be if array.length is less than or equal to 1, return array. So the idea being that if you just break all these individual elements into their own array, they're going to be sorted when their length is 1 or less. Then we're going to slowly add them back together a piece at a time. And then those pieces are going to be sorted. And then we're progressively going to add those pieces up together. And those are going to be sorted. And we're just merging them with our merge function we created up here. So the first thing we need to do, though, is define a midpoint. And the easiest way to do a midpoint in this scenario is to say let mid equal array.length divided by 2. So if our array was length 6, the midpoint would be at index 3. But just to be safe, on the safe side, we're going to use math floor. So in case we had an odd length array, like 5, our midpoint would be 2.5, but if we use math floor, it would be 2, and that would actually make sense and wouldn't screw up our code. Okay, so that's our midpoint, and then now we need a left and a right, because we're going to return merge with left and right. And if you recall, our merge function just takes two arrays and then merges them, just like we're doing, nothing too crazy. So we need to define that left and right variable. So I'm going to say let left equal array.slice at 0 to mid. And then I'm going to say let right equal array.slice. And I can just put in mid here because it's going to cut everything from mid on. So let me just actually comment out this merge function real quick. And I just want to show you what our left and right values are. So here's left. So left would be that 532. And I'm assuming mid is right here. And then right should be that 110.9. And it is. Okay, cool. So as you can see, the way it is right now, when we run this function, it would not trip our edge case of 1 or less because these arrays are length 3. So we actually need to continuously and recursively call merge sort on our left and right values to break them down further. And this is kind of the confusing part about the merge sort algorithm, is we're recursively doing this, but basically just remember you're basically chopping these values up into arrays, right? You're going to keep chopping them up, and then you're going to chop these values up. So this would be like, what, 5, and then 3, 2, and this would be 1 and 9, 10, and these are going to be sorted, by the way, so my mistake for that. That should be like that. and then you're breaking them up into individual array elements like this, so their own array, each one of them. Okay, and would have been smarter if I would have done this with a smaller array, but trying to just illustrate what's going on. And when they're at one, when you have the array now is split into like 6 different arrays, these are all sorted arrays because there's only one element in them. And then now you're going to slowly combine them back, but now they're going to be sorted. So this would be like 1, 3, and this would be 9, 10. You can see, and the way we're doing this combination of sorting, we're just using that merge function we created up here. But the logic in here is a little confusing because it's done recursively, and it's kind of like, there's a lot of steps to it, but conceptually, I think if you can just understand this part of it, you should be fine. So let's just see if this actually works. I don't know if this is going to work yet. And it does. Cool. So let's add in some different values. Looks like it's good. Let's put something crazy at the start here. All right, so there you have a merge sort function. Just remember, once you make this merge function right here, that's like 50% of the battle. And then you're just going to be chopping it up every time. Remember, you're chopping up that initial array every time, halving it, and then you're halving that until your length of each one of those array values is 1 or less. And then you can start calling the merge function because you have a left and a right value established. So I hope I didn't lose you guys too hard there. But thanks for watching, and I hope to see you in the next video.